Okay, you're welcome to Sa Majesty's World Science channel. In this video, I will be handling the physics WAEC past question over here. We're handling the physics WAEC past questions to prepare you for the forthcoming examination, and this one I'll be handling the objectives, the 2024 WAEC past questions. So, as you can see there on the screen, that is SC 2024. All right. So we'll go straight to question number 1. Question number 1 says, the vacuum and the severed surface of a vacuum flask wall are to respectively, that's the vacuum and the severed surface of a vacuum flask walls are to respectively do what? You know, in a vacuum flask, you have to maintain the temperature of the content by reducing heat transfer. And we have the 3 mechanisms for heat transfer, which are conduction, convection, and radiation. So conductions are done when the bodies are in contact, and solids have the highest conductivity when it comes to transfer of heat. So solid metals actually have heat transfer. When you hit one rod, heat transfers to the end of the other rod by conduction. But convection is just the transfer of heat within a medium or a fluid, which can be liquid or gas, like heating a water body. When water boils, heat transfers from the bottom to the upper by convection. And gases also, when you heat a layer of gas, the heat is transferred from another layer by convection. But radiation is just the transfer of heat, just like electromagnetic wave in form of radiation, which relies on the roughness and smoothness and shiny nature of the surface. Therefore, in a vacuum flask, the aim is to reduce heat loss from the vacuum to the environment, and also reduce heat gain from the environment into the vacuum. So what must we do? Looking at the option A says to minimize conduction and convection and prevent radiation. Now, they have 2 things, vacuum and then severed surface. Vacuum minimizes transfer of heat by conduction and actually by convection. But vacuum cannot eliminate heat transfer by radiation. Radiation continues even though you have created a vacuum. Remember, vacuum is a space of extremely reduced pressure. It's a kind of an empty space, but practically there is no empty space. There is still little thing, but rather we say a place of very much reduced pressure, okay? Because as far as conduction relies in contact, there will be no more particle to touch each other due to vibration to transfer heat. And there is no expansion, no space for gases to move in terms of convection. So vacuum is to minimize heat loss by conduction and convection. Then the severed surface is to reduce heat loss by radiation, because smooth surfaces minimize heat loss by radiation. Smooth, shiny surfaces minimize heat loss. So A says minimize conduction and convection and prevent radiation. Of course, preventing radiation becomes 100% not possible. So severed surface is shiny and is reflective, so it is not going to prevent, but rather it will minimize. B says prevent conduction and convection. Of course, vacuum will entirely prevent that. Okay, then minimize radiation. C says prevent conduction and minimize convection and radiation. So the correct answer to this should be, so the correct answer to question number 1 is option B. B is the most suitable, because smooth surface, severed surface, which is reflective, is to minimize radiation, and the vacuum entirely prevents conduction and convection. Remember, sea breeze and land breeze are all due to conventional current. Okay. Then question number 2 says, remember to ask your questions in the comment section. Question number 2 says the magnitude of the acceleration of a moving object is equal to the magnitude of the acceleration. Acceleration is change in velocity with respect to time. So we are looking at velocity over time. Now, looking at the options, option A say gradient. Remember, gradient here will stand for slope. Gradient of a displacement time graph. This should give you velocity, and velocity is not acceleration. Rather, acceleration is velocity, change in velocity with time, with respect to time. Then, gradient of a velocity time graph. Gradient of a velocity time graph, of course, is the correct answer, because velocity time graph is just a graph that velocity time, you are plotting velocity over time. So velocity is plotted on the y-axis, while time is plotted on the x-axis. So even when we say gradient of a displacement time graph, you are plotting displacement, which is s over time, which I told you is velocity. So the gradient of velocity time graph is like this. So option C says area below first time graph. First time graph is when you use the x-axis, the y-axis, you plot the y-axis and against the time, force against time, which provides the impulse. The impulse is what is provided by option C, area below a first time graph. Then D says area below a velocity time graph. It is not the magnitude of the acceleration. So the correct answer is B. So we move to the next question. Remember to ask your questions where necessary. Now we look at in which of the following, the area below the velocity time graph should be displacement itself. That's option D, should be displacement. Then B is the correct answer, like I said. Number 3 says in which of the following states is maximum pressure exerted on a person? Maximum pressure exerted on a person. First of all, the common idea is that pressure is equal to force over area. So this implies that the smaller the value of area, the higher the pressure. Because if force, for example, is 15 Newton or 15 kilojoule, whatever we say, and when area is 5, you see, it will give us 3. But if the area is reduced to 2, it becomes 15 divided by 2, which is going to give us 7.5. So the lesser the area, the higher the pressure. That's what it should be. Even in Boyle's law, if you reduce volume, automatically you are increasing pressure. Okay? Now, looking at this, that number 3 says which of the following states is maximum pressure exerted on a person? A person standing on 2 feet. When you are standing on 2 feet, there is a whole lot of the surface area, your whole foot is in contact. So let's see other options. Then C, option B says standing on 1 foot. Standing on 1 foot. Option C says lying on the floor. Lying on the floor, your area, most part of your body are in contact with the floor. So we have larger area. And the larger the area, the smaller the pressure, of course. Then kneeling on the floor. The correct answer is still B. Standing on 1 foot. So when somebody stands on 1 foot, the pressure is going to be maximum, while the pressure is going to be least for someone lying on the floor because of more area. So standing on 1 foot, you are exerting more force in a limited area where you are one leg, and you know you are not stable at that moment. Then number 4 says, what are cathode rays? Cathode rays are actually fast-moving stream of electrons. This is more of chemistry. You produce cathode ray by subjecting, you create a vacuum, bring a vacuum tube, draw the air out, make it a vacuum, then insert your electrodes, which you have cathode and anode, then apply a high voltage. There will be emission of electron, which will be forced to travel from the cathodes to the anode, and this is emitted as rays. These are being used to produce television in the television screen, to project images on the screen before the invention of the LED and so on and so forth. So in this case, one should note that in cathode rays, electrons move from cathode to anode, which is unusual for a normal electrochemical cell, where electrons move from anode to cathode. Remember to ask your questions where necessary. Please subscribe and share this video. I cannot do without you. This is Her Majesty Easy World Science channel. We are here to help you in science. But your little support is by subscribing and sharing this video. Thank you so far. Going to question number 5. Question number 5 says, capacitance of a parallel plate capacitor. The capacitance of a parallel plate capacitor, it gives us what? A, decreases when it is now asking us what happens to the capacitance of a parallel plate capacitor. Capacitor is just a pair of conductive plates with a dielectric, that is an insulator in between it, and this stores energy in form of electric field, unlike batteries that stores energy in form of chemical reaction. And capacitors releases huge amounts of energy once, but very short time. So it is needed in some appliances such as your camera flash. During the flash, you need a quick energy to be supplied, to supply enough voltage to bring that flash. So capacitor is not the same thing as battery, but both stores energy, but capacitor stores temporarily. Capacitor does the job of either holding a particular, keeping the supply of current steady for a short time. Is always very transient, like a supercharged mini battery, but it doesn't last at all. So now, how do we make it? You just need two conductive plates, and then you separate it by what? You separate it by, so maybe two metal plates in this case, which is now having the source of connection, and then it should be separated by an insulating layer. So over here is the dielectric. So the insulator is the dielectric. So this is just a capacitor. When you have two conductive plates separated by what? An insulator, and the electric current is supplied through one negative and one is positive. So remember, without the insulator, you have a short circuit, and this is no more a capacitor, it will bridge. Now, what this question is all about, the capacitance, that's the ability to store energy and release energy in form of electric field. Does it really depend on what? First of all, if we increase this particular, if we increase the area of the dielectric, definitely we will follow the equation which says that the capacitance of a capacitor is C over E A over distance, while the E is a constant, and then the D is the distance between the two plates, while A is the area of the metallic conductor. So with this, it shows that the larger the distance between them, meaning the higher the thickness of the dielectric, the lesser the capacitor, the capacitance of the capacitor. But without the dielectric, it makes sure that this D is 0, and when this D is 0, it gives us that this expression is now an infinity, which is not going to work. But I told you that when distance is increased, of course, the capacitance decreases. But without the dielectric at all, the capacitance, it breaks down. It is no more even a capacitor, rather it will give us a short circuit, because it's just like bridging it together. Okay, so the mechanism by which capacitor stores charge will be discussed on a separate video by other experts. So keep on watching, and let me go back to the options. But I've explained what capacitors are, whereby the capacitance of a capacitor is given by EA over D. A is the area, while E is the constant, and then which is constant called what you can see there on the screen. Then D is the distance, which is telling us the thicker the dielectric, the lesser the capacitance. But without the dielectric, it is a zero. You are given the expression, the 0 below makes it an infinity, and this is impossible. So it cannot work, rather you have a short circuit. So go back to the options. What do we have? Option A says that the capacitance of a parallel plate capacitor decreases with the separation between the plates. Decreases when the separation between the plates decreases. No, the separation between the plates, when it decreases from what I told you, capacitance increases. But when you decrease it to 0, it means it's no more a capacitor. Then B says the capacitance increases when the potential difference between the plates is increased. Capacitance of a capacitor is not affected by potential difference in any case, so that is not a good option. C says the capacitance of a parallel plate capacitor is greater without a dielectric between the plates than with dielectric. It's not true. Without dielectric, it will be a short circuit, and it gives you D to be an infinity from the expression I gave you. C equals over D. So if this distance, which makes the whole thing determinant on the distance, when it's 0 is in infinity, so the correct answer is D, is greater when dielectric is greater with dielectric between the plates than without the dielectric. So that's what I have to offer. Now we have the other number 6. Focus and continue with the nice guy, Lotana Charles. The guy that once made 99 in mathematics. He's a wonderful guy in physics and mathematics. So enjoy the rest of the video. Thank you. As you watch until the end, ask your questions, for I am here for you. Much love. Enjoy.
Now, when we look at question number 6 here, let me just drag that here. So it says the diagram PQ, the diagram above illustrates the motion of a cyclist from P to R. The distance is determined by the what? Now, this is also a velocity time graph. Gradient of the velocity time graph is the acceleration. So we cannot say any gradient here can be the distance when we know that gradient is the acceleration. So C and D is already not an option. So the two options are here we're going to look at is A and B, the area under QR and the area under PQR. But let me explain that the reason why the distance is the area of the velocity time graph is this, because when we look at this shape, the cyclist traveled from P to R. This is a trapezium, and remember the formula for distance is velocity multiplied by time, as you can see here. So in order to suit this formula here, we are going to look at the normal graph where this velocity, where this axis is the velocity axis and this is the time axis. So this is also the y and x axis. So which situation will bring us to multiply the y by x is actually going to be the area of the shape to find the area covered by the distance here, because distance of a graph is actually the area of the shape of the whole graph here. So now, so the distance here will be the area under PQR, because the cyclist also traveled through Q too before he reached R. Not that he went straight like in a straight line, more like this, but he traveled and passed this point Q here. So the correct answer to this question will be B, the area under PQR. Let me just erase this working cells. Then it said a ray of light travels from a less dense medium to a denser medium. How are the speed and frequency of the light affected? Now, when a ray of light travels from a denser to a less dense medium and bends, now the frequency always remains the same. Frequency is always the same. That's the initial frequency the light had will be equals is always the same as the frequency that the light will have after bending. So the frequency will be the same, and that of the speed of the medium, as you can see, it depends on whether the light is traveling from a denser to a less dense medium or from a less dense medium to a denser medium. In this question, it says it travels from a less dense medium, something like air, to a denser medium like water. Let us represent back by using W. So when a ray of light travels from a denser to a less dense medium, the speed decreases because it has a higher amount of density. So the correct answer that fits this situation is D. The speed decreases and the frequency remains the same. Next question says the function of a fuse in an electric circuit is to do what? Now, the fuse in an electric circuit is to make sure that the current in the circuit does not exceed a certain value and cause any power outage in the system. So the function of the fuse will be to break the circuit when the current exceeds the certain value. This other also does not fit the function of the fuse in an electric circuit, because the fuse will trip when the current is exceeding, or when the circuit is exceeding the current value. A body moves with uniform velocity when the resultant force is on its dash. Now, a body moves with uniform velocity when the resultant force is is greater than the frictional force acting on it. The answer to that, okay, a body moves with uniform velocity when the resultant force on it is equal to zero. This is because at constant velocity there is no acceleration, as the velocity does not increase. Using the formula F is equal to ma, that's our force is equal to our mass times acceleration. And we are saying that remember when a body is moving in uniform velocity, our acceleration will be zero, because the velocity will continue to remain the same throughout as the body moves. So when we are multiplying by the mass of the body, the force will be always equal to zero. That's the resultant force of the body. So there will be no force acting on the body when it's moving on a uniform velocity, because there's no acceleration in it. So the correct answer to this question will be C. Next question is number 10. The law of conservation of momentum is stated for a closed and isolated system. What are the two conditions for a system to be closed and isolated? Now, the two conditions for a system to be closed and isolated is when there is no external force acting on the system and there is also no change in mass of the system. That is A, Because remember, when we look at the law of conservation of momentum, we have MAUA, that's M standing for the mass of the first object about to collide, and U standing for the initial velocity of the first object. MB standing for the mass of the second object, and UB standing for the initial velocity of the second object that is about to collide with the first object, will be equal to the MA, that is the mass of the first object, multiplied by the new velocity of the first object after e hits that second object and starts moving in a new direction or possibly in the same direction. Then we have plus MB. MB is the mass of the second object in impact, while VB is the new velocity or the final velocity of the second object after the impact. Now, as you can see in this formula here, the MA is equal in both scenarios even after the impact. So it does not change throughout the impact in the system, and there's also no external force acting on the fixed system for the law of conservation of momentum to be stated. For the law of conservation of momentum to be observed, there has to be no external force acting on it. It's almost like when you are throwing something, well, it's almost like the constant for the acceleration due to gravity. The acceleration due to gravity is the same for every object. That's when no external force is acting on it, like wind and other forces too. Because when external force is acting on you find that two objects may not fall at the same time. But because there's no external force acting on it, we have found that the constant of this acceleration due to gravity will be 10 meter per second square. So when we look at, so the next question is, a stone of mass 200 gram is tied to a string, is attached to a string, is made to revolve in a horizontal circle of radius 1.5 meter at a steady speed of 5 meter per second. Calculate the tension in the string at the bottom of the circle, and they gave us the constant of the acceleration due to gravity as 10 meter per second square. Now, to calculate the tension on the bottom of the circle, we need to know all the forces that act downward. So if I were to draw a scenario of this is the stone. This let's assume that this is the stone and is tied to this string over here, maybe on the wall side, and is made to revolve. It's constantly revolving in this direction. Also, maybe an external force acts on it and it stops. So as it continues to revolve, when it's at its down, when at the lowest point now, we're going to look at all the forces that act on it at this point because it said when it's at the bottom of the circle. So to calculate the tension, let's look at it. So the forces are the weight of the object. That's the weight is the mass times the acceleration due to gravity. That's mg. And also the net force acting on the object too. That's force, the net force acting on the object. So and the weight will be equal to mg. So mg, they gave us the mass of the stone as 200 gram. So first of all, I guess convert the 200 gram to the standard mass that we use to solve this question. That's 0.2 kg. That's dividing the That's after we divide the 200 grams by 1000, we're going to get a value of 0.2 kg. And it said, and they gave us the acceleration due to gravity as 10 meter per second squared. So multiplying this by 10, the final weight of the object will be 2 newtons. So I've already gotten the weight of the object. Now let's get the net force of the object, because to find the tension, that's the total tension T, it will be equal to the total weight and the net force acting as it's rotating in a circle constantly, just like the diagram that we made earlier on here. So to find the net force, the net force is also equal to the centrifugal force as it's moving, F. And the centrifugal force, let us call this CF, denoting centrifugal force. Centrifugal force of any object moving is mv square over r. So m standing for the mass of the stone, v standing for the velocity, and r standing for the radius. So to find this, the mass of the object here in kilogram, remember, because we are going to use the standard mass, not the mass that they gave us here in the question. But if it's already, if, assuming it was already in kilogram, we use the same value here. But the standard mass in this equation here is going to be in kilograms. So we have to convert to the kilogram value here. So this will be 0.2 multiplied by our velocity or speed is 5 meter per second. So that will be 5 squared from this mv square here divided by the radius of the circle is 1.5 meters. It's already at the standard value, so you don't need to convert it. It's already at meters. That's the standard value for the equation for the formula. So if we are to multiply, this will be 0.2 multiplied by 25 divided by 1.5. So the force here will be, after the calculation, it will be 3.33 newtons. 3.33 newtons. We just approximated it, though there are more trees, but we're going to just approximate this value. So remember that the tension is the weight of the object plus the net force acting on it. That's the centrifugal force acting. So we're going to add these 3 newtons to the 3.33 newtons here. So adding it together, we're going to get a total of 5.33 newtons. And so that I can fit the options here, we can also approximate the 5.33 newtons to about 5.3 newtons. So this is going to be our final answer here, 5.3 newtons. So let's move on to the next question. It says, number 12, it says to convert a milliammeter to an ammeter, it is necessary to connect a resistor of what? Now, in order for us to convert a milliammeter to an ammeter, we need to make sure that it can read a higher we need to make sure that it can read a higher amount of of amperes. That's a higher amount of current than it usually does, because a milliammeter reads a very small amount of current and an ammeter reads higher value of current. So we need to make sure it can register at the highest amount of current in order for it to read it, for it to read the current properly, because a milliammeter can only measure small amounts of current. So he said it is necessary to connect a resistor of dash. So now for us to read a high amount of current, we need a low value of resistor, and it must be connected in parallel. This is because whenever a circuit is connected in parallel to another, whenever a whenever two resistors are connected in parallel, the amperes remain the same in this case scenario. Sorry, does not remain the same. It moves more to one to the first to the first to the first milliammeter, to the first resistor here. That's where our milliammeter is, and that's where most of the arms will move to in order for it to read a high amount of amperes. So the correct answer to this question will be C. And it also has to be in low value, because if it's a high resistance value, it will not read a very high amount of ammeter. And remember, we need our milliammeter to read the highest possible or amps that it can read from a particular electric circuit. So we have number 13. It says, as an object is placed 1.5 meters from a plane mirror, how far is the image from the object? Now, when we place an object, let's assume this is an object. When we place an object 1.5 meters from a plane mirror, the image reflected at the back, that's the virtual image at the back of the mirror, will also be at the exact same distance of 1.5 meters, and it will be laterally inverted. So to find the distance from the image to the object, it's good for one to not confuse this, because you might think it's 1.5, but we're not looking at the distance from the object to the mirror or the image to the mirror. We're looking at the total distance covered from this image to this object here. So now for us to solve that, we're going to add both these 1.5 meters together. So that will give us a total value of 3.0 meters. So the main aspect of this question is for you to get two these two values here, the distance from the image to this object. So that's 3 meters. So the correct answer to this question is A. Number 14, it says chromatic aberration of lenses in lenses can be corrected by using a combination of thin convex lens. Chromatic aberration of lenses can be corrected by using thin convex lens. Chromatic aberration of lenses is just a situation whereby the lenses would focus different colors, and it will not be able to focus a particular color. Rather, it will just spread out different colors, and the user who is using the lenses won't be able to recognize them because they will just be randomly spread out. But by using a thin convex lens, it will focus those colors at one point, enabling the user to differentiate and see them well. So the best scenario to correct a chromatic aberration of lenses in these options from these options here is a thin convex lens. So let's move over to number 15. It says a cube of wood of size 10 centimeter floats vertical in water with 4.5 centimeter of its length submerged. So let's assume that this is our cube and this is 4.5 centimeter of its length, which is submerged in the water. And they say we should calculate the density of the wood. The remaining part here will be 5.5, subtracting, given that the whole length of the wood is 10 centimeters. So the remaining distance above the water level will be 5.5 centimeter. So they say we should calculate the density of the wood. Now, using the formula density of cube, let's denote that using D and small c, multiplied by the volume of the cube, that's Vc in short, is equal to the density of water, let's use dW, multiplied by the volume of water that was displaced by the material, or in this scenario is the volume of water displaced by the cube. So the density of the cube of the wood, or you can call it what you want, of the cube here is what we are looking for. So we can still denote this as dc. And the volume of the cube is, we're not also giving the volume, but we're giving the length, and is a cube of wood. So to find the volume of a cube, we need, the formula for volume of a cube is L cube. That's the length cube. So given that length of the cube, or of the cube has each length as 10. So this will be 10 cube. So total volume of the wood will be 1000. So I'm just going to put that over here. And it will be equal to the density of water was given in the question here, 1 gram per centimeter cube. Even that our units fits the unit, different units that we're using here, like centimeter, it actually fits the unit for the question. So, and the volume of water displaced is what we're going to also find here. So to find the volume of water that was displaced by the cube, we're going to multiply the 4.5 centimeter. That's the 4.5 centimeter of the 4.5 centimeter, denoting the length of the cube that was displaced by the water, times 10, that's multiplied by the density of the water. In this case, we're going to use 10 twice. So this will be 450 centimeter cube. So we can just multiply everything out here. So this will be 450 over here. So, and this will be 1000 DC. This 10 times 10 is just the density that we're going to, it's just the other area of the other length of the water, which is 10 multiplied by 10. Because we're going to denote it, we're going to also use the total length of the wood in this situation. So that's 450 centimeter cube of water. So that's why we use the 10. So we're going to, so to find this, we're going to divide both sides by 1000 here. Divide by 1000 here. And our the density, so the total density of water, the total density of the cube rather, or wood, because we have W here. That's why I decided to use cube. Will be 0.45 cent 0.45 gram per centimeter cube. So the correct answer here will be A. So the next question says a temperature of 60 degrees Celsius is equivalent to what in Fahrenheit? Now the formula for to convert Celsius to Fahrenheit is, let me put my pencil on. So the formula to convert Celsius to Fahrenheit would be degree Fahrenheit is equal to degree Celsius multiplied by 9 over 5 plus 32. So in order to find our degree Fahrenheit, this will be equivalent to our degree Celsius in the question given here is 16. So we are just going to apply it here. Instead of putting degree Celsius again, we are going to put 16 multiplied by 9 over 5 plus 32. So after solving everything, our degree Fahrenheit is going to be 140 degrees Fahrenheit. 140 degrees Fahrenheit. So our final answer will be D, 140 degrees Fahrenheit. This was also A too. So the next question states all the following uses are practical applications of X-ray except the treatment of tumors. The term X-rays can be used to treat tumors, determining the depth of a mine. No, X-rays cannot be used in determining the depth of a mine. C. Dental operation. Yes, X-rays can be used in dental operation, and X-rays can also be used in detecting fracture in bones, as stated in D. So the correct answer to this question will be B. Number 18 says two isolated charged pairs, each of magnitude 1.0 times 10 raised to power minus 6 times 10 raised to power minus 6 coulombs are separated by a distance of 2.0 times 10 raised to power minus 1 meters. Calculate the magnitude of the electrostatic force between them. So in order for us to calculate the force, the electrostatic force, we are going to state the formula over here, which is equal to K Q1 Q2 divided by our R square. Sorry, this is not looking so clear. So our K, which is given as a constant here, is 9 times 10 raised to power 9. And we are given that the particles, or the spheres rather, have the two spheres have the same magnitude. So I'm going to put 1 times 10 raised to power minus 6 coulombs. And we're also going to put another 1 times 10 raised to power minus 6 coulomb. And the radius in this question here or r denoting the distance is 2 times 10 raised to the power minus 1 meter. So this is 2 times 10 raised to the power minus 1, and it's all squared. So anyways, after we solve this whole question here, our final answer is going to give us 2.25 times 10 raised to the power 2.25. Let me just separate it here. Times 10 raised to power minus 1 Newton. This is our final answer in this question. So this will be A. So our next question here is showing a diagram. The diagram is showing us a lamp. It says in the circuit diagram above, which lamp causes the other to go off? Now when we look at a circuit diagram, you can see that the balls are connected in series to each other. which means that the circuit is flowing all around, passing through all these bulbs here, and then goes back again and rotates. So whenever bulbs are connected in series to each other, the one that is nearest to the series, if it breaks, it will break the whole circuit. So no electricity will continue to move out to either of these other bulbs here. And the one that is closest to the path on the circuit here is light bulb S, or the S light bulb. So the correct answer to this question is S, because if S goes off or it breaks or is disconnected, the whole circuit will be disconnected and the other light bulbs will immediately go off. So it's S that is the correct answer here. Because circuit reaches S first. So we're going to look at the next question. It says a particle of mass 3.6 times 10 raised to power minus 6 kg revolving around the earth has a, let's just write that down because it might be too small. So we can see that the mass of the particle is 3.6 times 10 raised to power minus 6 kg and is revolving around the earth at a radial acceleration of 4.3 times 10 raised to power 7 meter per second square. So the acceleration at which the particle is rotating is 4.3 times 10 raised to power 7 meter per second square. So in order for us to calculate the centripetal force here, we can use the simple formula, which is force is equal to the mass of the body multiplied by the acceleration. And the mass of the particle here is 3.6 times 10 raised to power minus 6. I was going to put that down here. And the acceleration of the body is 4.3, that's multiplied by 4.3 times 10 raised to power minus 7 times 10 raised to power 7 rather. So after our multiplication here, the correct answer to this question would be 1.55 in up to the nearest hundredth if we're approximating times 10 raised to power 2 newtons. So this will be our final answer. So we're going to mark it as B. So next question says that for a convex lens to form a real image, the distance between the object and the screen will be what? So it says equal to the focal length of the object of the lens, less than the focal length of the lens, twice the focal length of the lens, or 4 times the focal length of the lens. So for us to find to see the situation where the lens will form a real image, let's just draw a quick lens diagram here. This is our principal axis, can just notice by PA. Our convex lens over here, the middle line here is our optical center, which can be noted by OC. So if a ray of light comes, so this is our focal length, this is the twice the focal length here, this is the focal length in the other side where the image is going to be formed, and this is the distance of twice the focal length as a demonstration. So I say, where would the object form a real image? A real image is an image that is formed and can be and in such a way that it can be displayed on a screen. So in the situation of lenses, for a real image to be formed, it has to be formed behind the lenses. There are situations where a virtual image is formed where the image is formed in front of the lens, which means that it cannot be displayed on the screen. So, but if it's formed behind the lenses, it can be displayed on the screen. That's why we call it a real image. So in the case here, when we look at equals to the focal length of the lens, we're going to look at each scenario here. If it's equal to the focal length of the lens, assuming that there's a light traveling parallel to the principal axis here on top of the object, if it hits the optical center, it will bend. Now, when a light is traveling parallel to the optical center, sorry, to the principal axis rather, it will the light after bending in the convex lens must pass through the principal focus here. Now, if now we are going to also draw another light that will regardless still pass through the principal focus, that will pass through the optical center on its own. So after passing through the optical center, we can see that it will form after from the ray diagram here, we can see that eh, so in our ray diagram here, for a convex lens to form a real image, that's the distance between the object and the screen will have to be twice the focal length of the lens, because when the object is twice the focal length of the lens, assuming we have our convex lens here, this horizontal line we just drew is the principal axis, that's and this vertical line that we're drawing in the middle of the convex lens is our optical center. Can denote this by OC, and this can be denoted by PA. That's principal axis, and our OC is our optical center. So if a ray of light passes parallel, let's assume an object is standing at 2f, that's twice the focal point. This is also 2f too. That's where the image is expected to form behind the lens. And so this is f. Let's just erase that. This is f, and this is also 2f here behind f. So assuming our image is around here, if a ray of light passes perpendicular to the principal axis, when it passes through the optical center of the convex lens, it will bend and pass exactly through the focal point here. Now, if a light, assuming we have another light again, because there are a lot of lights, but I'm going to just use two rays of light for this demonstration. But there are a lot of rays of light that pass through this convex lens. So if another ray of light passes through this optical center here, as it passes, they will converge somehow at this point here, around here, to form an image that is meant to be equal. If there isn't a mechanical instrument to denote to draw the lines, you realize that after drawing it, it will form an image exactly equal to the object, to the initial object here. Though it will be inverted, as you can see, it's upside down, but it will be exactly the same size, and it will be formed behind the lens. And remember, any image formed behind the lens will be real. In all the other cases here, the image will either be formed at infinity, or and most of them will also be formed in front of the lenses too. The only one that we can see forming behind the lens, or the only case scenario that we can see forming behind the lens, is C. That's twice the focal length. Then when we look at number 22, it says determine the peak value of the applied EMF. The peak value of a volt, we have our LRC here. So if I were to draw the diagram, this is how it will look like, where this is our L, this direction here is our R, this direction here is our R, and this direction here is our C. So they said, so it was stated in the question that the value of our L is 6 volts. So this is 6 volts, and the value of our R is 3 volts. and the value of our C is 2 volts. So in order for us to find the value of our peak value is just the resultant volt. That's what we are going to have here. We are first going to do the subtraction between the L and C to find the remaining volt that will be running at the horizontal axis. So when we do the subtraction, L minus C, this will be 6 minus 2, which will be equal to 4 volts. Now that we have 4 volts running at the horizontal axis here, to find the resultant volt here, this will be something like a right angle triangle, where our 4 volts will be the adjacent line here and our 3 volts will be the opposite line. So using our Pythagoras theorem, where this will be where the resultant volt here will be the square root of 4 squared, the square root of 4 squared plus 3 squared. So our resultant volt will be 5 volts. So the correct answer to this question will be C, 5 volts. The next question states that a 2 UF or a 2 microfarad capacitor is connected directly across a 150 volts RMS being root mean square, 60 hertz, that's the frequency, 60 hertz AC source. Calculate the RMS value of the current. So to calculate the RMS value of our current, we are going to use this formula because our I RMS is equal to our VRMS, that's the potential difference in volts, the root mean square of the potential difference in volts, divided by our XC, that's the resistance of the capacitor. The C standing for the capacitor here. So this is what we're looking for. So this will be equal to the volts. The VRMS was given here as 150. Well, we're not given the current, we're not given the resistance here, XC, the resistance of the capacitor, but we're given the frequency, being 60 hertz. So in order for us to find the the value of the current here, we're going to first find the resistance, and the formula for resistance that fits this question here is 1 over 2 pi fc, or rather we can use xc instead. Xc is equal to 1 over 2 pi fc. So our xc will be equal to 1 over, let's use 3.142 as our value of pi. So that will be 2 multiplied by 3.142 multiplied by our frequency, which is in hertz, is 60. Our capacitance, which is in farad, is meant to be in farads, not microfarads. We're given 2 UF. So in order to convert microfarad to farad, I'm going to multiply this by 2 times 10 raised to the power minus 6. So this will be multiplied by 2 times 10 raised to the power minus 6 farads. So after the whole division here, our XC is going to be equal to, our XC is going to be equal to 7.5 0.54 times 10 raised to power minus 6. So this will be the final our resultant here. We're not yet through the question. I say we should find the RMS value of the currents, which is IRMS. So we are going to put, instead of putting x in now, we are going to put 7.54 times 10 raised to power minus 6. Or our final answer in this scenario will be 0.160 amperes. Yeah, we're meant to do 1 divided by this 7.54 times 10 raised to power minus 6. I was where we got it wrong. So that would be 1, instead of putting this 7.54 times 10 raised to power minus 6 again, we're going to put 1.32 times 10 raised to power 5. So if we do our division here, it is going to give us 0.155 amperes approximately. Okay, let's move on to the next question. The next question is, a body of mass m is projected vertically upward. So let us assume that this is a projectile motion here. This is our body. This is the body here. It's projected at the vertical upward. It's projected vertically upward at the velocity y. At what position would the potential energy be maximum? So the ball was projected and later hit the ground. Let's assume from the ground, it was projected upwards. So they're saying what position would the potential energy be maximum? For us to solve this question, we have to look at the formula for potential energy. Formula for potential energy: PE is equal to mgh. So now for us to find potential energy in this question, our mass here, the mass of the body is not given here, so I just going to remove that. So what I going to look at is the PE here will be GH. So for us to multiply that, we have our velocity, but we don't have our height. About that, we have V square is equal to U square plus 2GH. So assuming our V is given here as Y square, we're going to make H the solid of the formula. Our initial velocity is 0 because the body was at rest before it was thrown. And we're going to put 2GH. So to make the H solid of the formula, I'm just going to come up here. So this would be Y square is equal to 2GH. Now I'm going to divide both sides by 2G to cancel out, to make H stand alone. This is Y square, not 2Y. Sorry if there's any mistake here. So this will cancel this over here. So our H will be equal to Y square over 2G. So remember that we have our G here. So I'm still going to multiply it by G. So when potential energy is acting on a body, there will be no acceleration due to gravity acting on it, because the body will be at maximum height, because it's at this position, that this position the maximum height of the body when it's projected, that it will experience maximum potential energy. Let's notice by putting PE max. So since it's experiencing it at this point, the acceleration due to gravity is 0. So there will be no acceleration due to gravity acting on it. So the only thing that we're going to use to calculate is the height, which we made the sort of the formula and found here as y squared over 2g. So the correct answer to this question would be C. Then the next question is light of energy 1.52 times 10 raised to power minus 16 joules is incident on a metal of ejected electrons with maximum energy of 8.0 times 10 raised to power minus 19 joules. Calculate the threshold frequency of the metal, and we have the Planck constant given here. So for us to calculate the threshold frequency, we are going to use this formula E minus EO. That's EO representing the energy of the light, and E representing the energy that was incident on it, is equal to HF. H is our Planck's constant and F is our frequency. So our E here is 8.0 times 10 raised to power minus 18 joules minus the energy of light that was incident here is 1.12 times 10 raised to power minus 18 joules is equal to our Planck's constant here is 6.826 times 10 raised to power minus 34 Gs, but we don't have our frequency. So making the frequency sort of formula here, we're going to do our frequency to be equal to 8.0 times 10 raised to power minus 18 minus 1.212 rather times 10 raised to power minus 18 all divided by 6.826 times 10 raised to power minus 34. So the final answer to this question would be 1.2. After solving, it would be 1.2 times 10 raised to power 15 hertz.
Learn science for free with Sir Majesty Easy World Science. Master chemistry, biology, and physics on our YouTube channel, where we offer comprehensive tutorials, exclusive science practical demonstrations, real-world applications of scientific knowledge to solve environmental and human challenges. We also specialize in building and equipping science laboratories with quality and reliable services. Call WhatsApp +234 706 516 6217. Join us and elevate your learning experience. Stay majestic.